Hi, Algebra students. Welcome to Section 4.5, Analyzing Lines of Fit. You learned in Section 4.4 how to draw lines of fit by hand on a scatter plot. And now we're going to use this fancy thing called a graphing calculator that you all have been begging us to use all year long. So today is the day. If you do not have a graphing calculator, that is okay. These fancy devices called the iPad have something similar. And I will show you how to calculate lines of best fit using both options. Okay, so if you have the graphing calculator, you're going to want to listen to the first part. If you have the, if you don't have a graphing calculator, you can go ahead and skip ahead to where you see me working on the iPad. Okay, let's do some quick vocab, and we will come back to these words several times throughout this lesson, so no stress. A residual is a value that shows how far off the actual point is from the line of best fit. So if you have your line of best fit and the point is here, the residual is that value, how far away the point is from the line of best fit. A linear regression is the process in which we find the line of best fit using the calculator or using Desmos if you don't have a graphing calculator. A correlation coefficient is used to determine how closely connected the data sets are. We'll talk more about that in a little bit. And then causation is when one variable causes a change in the other variable. So at this point, if you have a graphing calculator, go ahead and get it out. If you don't, you can either watch or you can skip ahead to where I start doing it on Desmos. Okay? And I'm going to do something really cool on my screen, hopefully. I just tried it. Oh, no, that's not what I wanted. I'm going to try to make this smaller. No. I just did it. Here we go. Yeah, look how cool that is. You can see both the screen and the Zoom screen. Man, technology, I've come a long way. Make this a little bigger. Okay. So basically you're going to follow the instructions that are in your notes while you are plugging these buttons away on the calculator, and I'm going to show you how to do that as we go along. Okay, so your first thing you're going to do is you're going to go to second, y equals, and your plot probably has off highlighted. Okay, you need to highlight over using the left hand arrow and hit enter to turn the stat plot on. Once again, I got there by hitting second and y equals. Make sure plot 1 says on. If it does not, this will not work. Okay? Now we need to enter our data. So you're going to go to stat and edit, and you're going to either click 1 or click enter. Either way will get you there. And now I have already pre-entered in my data to save time, but all you have to do is hit 1 on your calculator and then hit enter. 2 and then hit enter. Then you arrow over 27, then hit enter. Okay, make sure you have the same amount of values in L1 as L2 so that you don't mess it up. Go ahead and hit pause if you need to enter this data. From there, we're going to hit graph. And now mine's really pretty because I tested it. Yours probably, if I were to guess, looks like that. And if yours looks like that, the way we fix it is you hit the zoom button in the center, and then you hit zoom 9 because we're graphing a scatter plot. So zoom stat will make sure it includes all of the points that you have entered in the table. So what the calculator is going to do is it's going to draw a line that perfectly represents that data. And the way that it does that, the directions are right here. So that was my zoom 9. Now I'm going to calculate my line of best fit. So I'm going to hit stat. I'm going to arrow right to calc. And I'm going to arrow down to 4, linear regression AX plus B, or you can just hit the number 4, either way. Your X list is your L1, your Y list is your L2, that's what should be there. You're going to arrow down to where it says calculate. Okay, so it gives us an A value, a B value, an R squared value, and an R. Now, if I were to bet your R squared and your R values are not turned on, so the way we get those turned on, I bet you yours looks like, if you see the bottom of my screen, I bet you yours looks like this. So the way we get the R squared and the R is you hit second, 0 to bring up the catalog, And the catalog's in alphabetical order. And in order to not just keep scrolling for 10 hours to get to the D's, if you hit X to the negative first, there is a D there in the top right-hand corner of that button. And so that's just a shortcut to get us to the D's. So you're going to scroll down until you see diagnostic on, which is right there. Hit diagnostic on, hit enter again, and now you can go calculate your linear regression again. Stat, calc, 4, arrow down, arrow down, arrow down, arrow down, enter. And now you should have all 4 values. Okay, so what in the world do all 4 of those values mean? I'm going to pull this up because this is the same thing and I can write on this. Isn't that cool? So this right here, A is your slope. We are going to round that to the nearest hundredth. So that's 5.88. Why they didn't use M, I don't know. They didn't ask the math teachers before they made this more complicated than it needs to be. B is still your y-intercept. That's a good thing. Same thing. So your y-intercept is 5.5... No. Yes, 5.54 if I round it to the nearest hundredth. And then we're not going to use our squared value, so we can cross that out. And this last value right here is R, and that's one of the vocab words we just talked about. That is the correlation coefficient. It's how closely the line of best fit represents the data. Okay, so 0.96, we'll talk about what that means here in a minute. So we've got our slope, we've got our y-intercept. You need to go back to y equals, and we need to plug in that information. So hit y equals, you're going to go to y1, and you're going to type in 5.88. You have to use the x that's next to the alpha, plus 5.54, which is our y-intercept. Once you do that, you're going to hit graph, and looky there, your line should go perfectly through the points. Notice it's not going to hit all of the points because it's a line of fit that best represents the data that you are given. Okay? Now, if you don't have a graphing calculator, now is your time to pay attention. I'm going to pull up the Desmos app, and hopefully my technology works, so I'm going to pause till I get it working. All right, it is important that you are using the Desmos app and not the Scientific app. So they look similar. Desmos has the graph, Scientific has the cube root of 27. So make sure you click the Desmos, and then I'm going to split screen so I can see both things at the same time, theoretically. Come on now. There we go. Okay, so to type the table into Desmos, remember you're only doing this if you don't have a graphing calculator. Okay, you're going to hit the plus button up in the top left corner, and you're going to hit table. And now you're going to type in the table. I'm going to pause to save some time. All right, after you have entered the table, literally all I did was hit the number and then the return button in the bottom right-hand corner, the blue return button in the bottom will get you to the next line. Okay? Now you're going to hit the plus button again to get your line of best fit, and you're going to hit expression, and here's where you have to remember what to type in. So x1 is our x coordinate, y1 is our y coordinate. We want our equation to be in the form of y equals mx plus b. Okay, so what you're going to type in, I'm going to write it first so that you can see it. You're going to type in y1, and then this is called a tilde or a tilde. I don't know how you say it, but it's a little curvy line. Okay, so you're going to type in y1 is equal to mx1 plus b. Okay, so it's kind of like y equals mx plus b, but a little bit different. Okay, so we're going to hit the y, then type the 1. It'll do it automatically. And then the tilde button, you have to hit ABC, and then it's right down in this bottom row. So if you go to the enter, I'm going to put my cursor right above it because I can't circle it because it's so low, but it's right there. You also can use your keyboard on your iPad. It's the you have to hold the shift and then the button to the left of the 1 if you want to do that as well. And then hit ABC to get the M. And then X, don't forget your 1, plus ABC, go to B. And looky there. So here, right here, 5.88, that is your slope. Y-intercept, 5.53. Same thing we got when we did linear regression on your calculator. Now, I know what you're saying. This is way easier than doing it on the graphing calculator. Yeah, it is. But you have to realize this is your guys' first year with the iPads. And this is our first year teaching with Desmos. So when we asked you to buy a calculator, we didn't really know this existed. So calculator's not going anywhere. It'll do you good the rest of your academic career. But either way you want to pick is fine with us. All right. Let's get back to our notes. So swipe out of Desmos. And let's go down to here and talk about residuals again. So remember, a residual is the difference of the y value on a data point and the corresponding y value on the line of fit. So if the data point is above the line of fit, okay, it is a positive residual. If the data point is below the line of fit, it's a negative residual, okay? And this distance right here is what the residual is equal to. So this would be a negative number, and this would be a positive number, because that's a positive residual, okay? Now, if this graph had numbers to it, it would be a little bit more easier to define. All right, so what you're going to do is you are going to hit pause right now. You're going to pick one of your methods, either the graphing calculator or Desmos, and you're going to enter this table in. Okay, do that now. All right, so I entered it in. I'm going to go to Stat. I'm going to go to Calc, arrow down to 4, Linear Regression, hit Enter. Arrow down to Calculate, hit Enter again. There's my slope. There's my y-intercept, and here is my correlation coefficient, okay? So you might have to jot that down. So 23.57 and negative 1798.56. So you're going to go over to y equals. So 23.57 was my slope times x plus, oops, not plus, minus, since it's a negative y-intercept, 1798.56. When you hit graph, remember you may need to do zoom 9. And once I do zoom 9, it's a perfect graph with the line of fit going through there. So the equation for the line of best fit, I know we just plugged it into our calculator. Let me pull it back up on y equals so we can copy it down. Y equals 23.57x minus 1798.56. Identify and interpret the correlation coefficient. So, oops, I just had that up. Let me get it back. Edit 4. So my correlation coefficient is 0.98. Okay, so it's a positive number. So it's a positive correlation. And then the closer the one it is, the stronger it is. So I would call this a strong positive correlation. Once again, the closer it is to 1, the closer the points are to the line of fit. The slope is 23.57. It asks us to interpret this. The y-intercept is negative 1798.56. And I am running out of time on this video, so we are going to do these final two in class the next time you see your teacher. Have a great day.